Alright, so another question for a quick revision of JEE Mains. If you want to watch more videos and solve questions with detailed solutions, watch this channel. We'll give you explanation and clarity. Don't forget to subscribe to this. Alright, let's move on to this question. So what is this question focused on? The question is focused on calculating the work done. It says there is a material that follows this equation. You have to find the work done at constant pressure. Since I am doing a quick revision of JEE Mains syllabus, starting with kinetic theory and thermodynamics, very important topics, very scoring also. I will just give you a brief overview of the concept of work done in thermodynamics. First, understand that very clearly. In thermodynamics, the concept of work done is essentially related to this idea that when the work is done, energy is transferred. When the work is done, energy is transferred. What happens to this energy? The energy can change the internal energy of the gas. It can change the temperature of the gas. It can also change the volume of the gas. It can also change the temperature of the gas. When we say kinetic energy, we also mean the temperature of the gas, right? So the context of work done, first of all, what does it do, right, has to be understood. The second important point is, now this was what all work can do. But the idea of work in thermodynamics is also majorly centered around the fact that the work done can be written in a certain manner. So if you look into this equation, right, PdV, the integral, right? So this is V1 to V2. The integral of PdV from V1 to V2 is also the main central theme, generally related to change in volume. The work done generally in thermodynamics is related to change in volume. It comes into play when there is a change in volume. Okay, very important point. Third very crucial point about the work done is whether the work done is positive or negative. The work is positive in expansion when the volume increases. That means the gas does the work on the surrounding. The work done is negative when the surrounding does work on the gas. It's a compression. The volume goes down. Okay, a very important point. Another fourth point about the work done, which you need to understand for your upcoming JEE Mains examination, is the fact that the work done is not a state function. That means it is not dependent only on the initial and final state. No, it is basically a path function. That means what path you take, right? That when you draw the isothermal lines, PV diagrams, and all of that, what if you take this path, the area under the curve changes. If you take this path, the area changes. If you take this path, the area changes. So essentially, from same point to same point, you can have different works because it's a path-dependent function. It's not a state-dependent function. Internal energy is a state-dependent function. Initial temperature, final temperature. What path you take does not matter in the case of internal energy. Why I told you internal energy? So that you can distinguish between a path-dependent function like work and a path-independent function like energy. Internal energy. Be very careful. I have written the word U here. Okay. What else can I tell you about the work done? Now, when the work is done, there are different types of thermodynamic process. Given that we already know that the work done is basically related to the concept of volume. Okay. Let's move forward beyond the concept of change in volume to different processes now. Now, different processes which are involved in thermodynamics, the work done is adiabatic. This is a formula. P1 V1 minus P2 V2 upon gamma minus 1 is equal to NR T1 minus T2 by gamma minus 1. Gamma, you know, is the adiabatic index, is given by Cp by Cd. What is the significance of gamma? It is basically all about how the energy is distributed in degrees of freedom. Triatomic gas, diatomic gas, how energy is distributed in each energy dimension or the degree of freedom. You can watch my videos on degree of freedom in kinetic theory of gas playlist to understand more about the concept of degree of freedom. Every degree of freedom has an energy. Anyway, let's talk about isobaric. What is an isobaric process? Isobaric is when the pressure is constant, right? So here we write P delta V. There is no need to write an integral out. P comes out and you can integrate delta V, which is V2 minus V1, right? And you get the answer. The other way to write isobaric constant pressure process is NR delta T. Okay? So P delta V is equal to NR delta T is your isobaric process work done. Memorize all these formulas. A lot of students falter just because they don't know the formula. And they think physics is very difficult, it's complicated, it's not clear. Just memorize all of these, understand them well, your job is done. Isocoric process. What's an isocoric process? An isocoric process is the one where there is no change in volume. So isocoric process, I told you the work that is associated with change in volume primarily. Now, if you have an isocoric process, no change in the work, no work done. W is equal to 0. So what happens? All the energy you supply to the system or take away from the system results only in change in the internal energy of the system and nothing else. Okay, so I've written if the delta V is equal to 0, then the work is 0, and therefore all the energy which you supply or take away is only going to impact the internal energy of the system. Now, the last one is the isothermal. nRT log of V2 by V1, not V1 by V2. The final state divided by initial. The same thing can be written in terms of nRT log of P1 by P2. P initial divided by P final. So, ensure that you understand its log of V2 by V1 and don't get confused between V1 by V2 or V2 by V1. It's V2 by V1 and P1 by P2 inside the log. So you understand isothermal, change in temperature is 0. If you have a delta T change in temperature of the system to be 0 because it's isothermal, then you can't change its internal energy, right? So delta U is anyway 0. Now let's talk about this question. I hope this quick revision of concepts of work done is helping you. And now let's get back to our main question, which I'm sure you've already read. In this question, you have this expression given. And it says it's a constant pressure scenario. As simple as that. And it does not follow. It's not it just says constant pressure, which means it's a kind of isobaric process, right? We understand the pressure part of it. So how do we do something like this, right? It's some material which is given to you. All right. Now, obviously, we know the idea of work done, right? So the work done we already know is something like this. We understand the idea of work done. I'll just reduce the size of the question now so that we can get some space to write. All right. Now, when I try to solve this, right, with the idea that actually the work done revolves around, okay, so we generally write it as V is equal to, right? So I know now that the pressure, right, that PV here is equal to alpha T square. So I can substitute certain values in terms of temperature. You can see for the isobaric process, it's P delta V or NR delta T. Change in temperature and change in volume. But there are two ways you can write an isobaric process, right? So I can write this as P is equal to alpha T square. I can substitute the value as alpha T square by V into dV. The constant, so alpha T square upon V is equal to P. If I take derivative of, so if I take alpha T square is equal to PV and I take derivative of both the sides with respect to say volume dV and or dP, then it is 2T dt by dV is equal to P, which is a number, right? It's a constant into 1. So my dV comes out to be equal to 2T alpha dt by dV is equal to 2T dt by P, right? This is my change in volume. So I can actually go back and use this expression, right? Which is alpha T square. I can replace dV with alpha T square by V 2t alpha dt by t, and this is t naught to t is equal to this, right? So this is my work done. And back to the work done expression. Alpha t naught squared is equal to this is equal to, so the, I don't need to write this pressure because so this should have gone away, right? So this is pressure, this cancel with this. So I am left with 2t dt alpha t naught to 2t naught is equal to 2t square by 2 alpha, and 2t naught minus t naught is equal to, sorry, this will be what? This will be integral here, t naught to 2t naught is equal to t squared. This is 4t naught squared minus t naught squared is equal to 3t naught squared alpha. This is your answer, right? So basically, this is a constant, right? So pressure is constant. Remember that. We have to use this, and we have to keep the whole equation in one variable, because in the work done formula, it's delta V and delta T. We will integrate only with respect to delta V or delta T. Okay, so you have to keep one variable here, not two variables. And the trick lies here. How do we get rid of one variable when we know the pressure is constant and we take derivative of pressure? It comes out to be zero. Then it becomes a standard question of replacing the way of cancelling P and converting the whole equation in terms of dt. So I hope this helps you understand the problem and solve the problem. So detailed explanations are available on this channel. Don't forget to watch any of the videos available. Thank you very much for your time, and wait for my next video.